going to welcome our speakers. They have and are continuing to have a long trip, and I'm looking forward to their presentation. Let's welcome Alana and Adam.
So, a few years back, Nova did a documentary that really kind of summarized what the problem is and how we're approaching it as a sector. My name is Adam, I'm with InStove. This is Miel, my wife, she's with InStove. And we're going to show you just a 3-minute summary of the problem that we address, and then we'll give a presentation. So, if you'll just join us for this.
They make this world black. My hands were like grease. You couldn't wash it away. The pots were black. The air was black. It was impossible for breathing.
We have seen forest reserves in 3 years completely gone, not a single tree standing there.
3 billion people use biomass, so wood, dung, charcoal, agricultural waste, and they cook those on very rudimentary open fires. That smoke kills roughly 2 million people each year, mostly women and children. So that's double the number of people that die from malaria each year.
The most dangerous activity a woman in the developing world can undertake is cooking for her family. And most of them have a baby on the front or a baby on the back. So that baby is inhaling so much smoke it's equivalent to 3 packs of cigarettes a day.
Cooking on an open fire contributes more black carbon to the atmosphere than all of the cars and the trucks in the world combined.
To make a ton of charcoal, it takes about 10 tons of trees. The forests are just vanishing.
The production and distribution of ultra-clean cook stoves that nearly completely eliminate smoke and reduce fuel consumption.
This new stove, look at this with your eyes. There is less smoke and it uses much less fuel. The black is gone.
I feel healthier, and my children, they are no longer sick.
What's the best way to design a stove to reduce smoke and increase performance? Our goal is to really bring researchers, designers, engineers, business people together. So it takes all of these people, all under one umbrella, to get the right stove into the hands of women. Normally a stovepipe would go down there, it's totally screwed up, the design doesn't work, it uses more than the open fire. I mean, just like 1,000 things go wrong.
We're, mentally prepared for corruption, so stuff's gonna get just lost, held up, arrive, broken. I reckon everything that can go wrong will go wrong.
The scale is huge. We need to make not just 100 million stoves by 2020, but we have to serve 100 million families. To really serve 100 million families, more like 300 million stoves. And this is off the chart. By manufacturing cook stoves, we're going to save thousands of lives, more than 100 million trees. We're going to create local viable jobs, and we're going to reduce indoor air pollution for millions of women. It's an incredible opportunity. We hope you join us.
So they summarize really effectively the problems of open fire cooking. It has a lot of different dimensions. So it starts with health, it affects environment, the climate, livelihoods, and it affects gender, disproportionately affects women and young girls. So it causes 4.3 million deaths, preventable deaths each year. It causes more emissions than all factories on the planet or all cars on the planet. You can take your pick. And it causes deforestation rates that are the equivalent of if the United States were to lose over 11 Yellowstones a year. And it's unsustainable fundamentally. It drives energy poverty, and it affects the health of women who spend most of their time, in some cases half of the time during the day, gathering the fuel, cooking food, which keeps them trapped in a cycle of poverty. So it's also a growing problem in Africa, which is increasing its demand for biomass fuel. So when you're looking at Africa right now, it's 2/3 of a billion people use firewood, and that'll grow by 2035 to about 1 billion people. So it'll increase its demand by about 50%. While the rest of the world is decreasing its demand for biomass, Africa is actually increasing its demand for biomass. And so there's a real need to address the problem now with an efficient solution. So we're in about 40 countries right now, and our approach, like they said, it's a solvable engineering problem, is to design an efficient stove that uses small wood and it uses less wood. And unlike the stoves that you saw in the video that focus on the household, we design stoves that focus on institutions. So when we say institutions, we're talking about orphanages, refugee camps, hospitals, clinics, community centers, and agricultural centers where you're using large open fires, but it's to meet many people's needs at the same time. And when you focus on those locations, you can really achieve impacts that are orders of magnitude greater. So to give an idea, you start with a household stove. And if you use an efficient household rocket stove for all of your cooking, which is a big if, in a given context, so in Nicaragua, for example, or in Africa, suppose you use an efficient stove for all of your cooking. In 1 year, you can expect to offset between 1 and 2 tons of CO2 with that one stove. An institutional stove, like ours, on the other hand, if you use it for all of the cooking in a given institution, it'll offset the use of about 97 tons of fuel, or 146 tons of CO2. So it's literally 2 orders of magnitude greater. So you can achieve a lot more impact per stove. And that means it's a lot easier to monitor that impact, it's a lot easier to train the people to use the stove, it's a lot easier to ensure the stove is being used. So to give an idea of what our stove is able to achieve, this is an EPA test that was done in 2015 on our stove, and it measures particulate matter emissions against carbon monoxide emissions. So the x-axis here is particulate matter and the y-axis is carbon monoxide. And ours is this triangle right here. So you can see that we emit almost as little as it's possible for a solid fuel stove to emit. So we're burning cleaner than natural gas or LPG stoves here at this point. We're producing less soot than kerosene stoves, and we're using biomass to do it.
Adam?
Yes?
What's a rocket stove?
So, go back here. A rocket stove is an elbow. Think of an elbow. You have an insulated combustion chamber, and then you have a horizontal chamber where you put your fuel in. Now think of your bicep as where you put the fuel, and your tricep is where the air flows in. They meet at your elbow. The air meets the tips of the burning sticks, and then you have combustion that takes place inside this internal combustion chamber. Because it's insulated, it gets extremely hot, and when you get that high temperature, you get complete combustion, which means that you reduce the amount of fuel that you need because you're using the fuel that you have more efficiently. So that reduces the fuel demand on the front end and reduces the emissions on the back end, because you're not going to be producing as much particulate matter or carbon dioxide, which are the byproducts of incomplete combustion. When you see a car chugging down the road and belching out smoke, it's not necessarily a bad engine, it might just be badly tuned. So that's the problem with open fires, is they're really poorly designed to maximize airflow and the mixing of gases that come from wood and oxygen. So rocket stoves were designed in Oregon, in a place called Cottage Grove. And we come from that same place. We trace our DNA as an organization back to Aprovecho that created the rocket stove, just like the other organizations on that video that you saw. So this is why it matters. This is from our first pilot project in Nigeria 7 years ago. This was Hajia Ismail Ismali. She said, "With the new stoves, my eyes don't water, my chest doesn't hurt, my back doesn't ache, and the baby on my back has stopped crying." So the Global Alliance for Clean Cook Stoves is a UN organization, UN Foundation organization that kind of umbrellas the sector. And they said, while some may say that the poor cannot afford to adopt clean cooking solutions, the opposite is in fact the case. The poor pay heavily for their lack of access to clean cook stoves and fuels. So as you saw down in Nicaragua when you were there, the poorest are the ones who are paying the most. They're not paying with cash, they're paying with their lives. So InStove was invented by Fred Colgan, my stepfather, and Damon Ogle. And their vision was that there's no sustainability to this program. You can't just build something in the developed world and just ship it to the developing world. You got to teach people how to fish. And so the InStove model was designed to be exportable. That is, not just the stoves, but the manner of their construction can be exportable as well. So all of the tools and all the jigs necessary to design our stove can fit into one shipping container and be sent anywhere in the world. Now the challenge is not a technical one. We can open up a factory. It's a relatively simple task. The really challenge is opening a sustainable, profitable business. Anybody can build the stoves. Not everybody can run a business sustainably and profitably. And so we have a model that can and has been proven to be able to open local production within 4 weeks, producing, as you saw, InStoves, which are the most efficient stoves in the world, as tested by the EPA. So we can build the best stove in the world within 4 weeks in a local production facility with the right partner. So I'll let my wife talk a little bit about the applications for stoves. Go, you can advance forward.
Sorry, my introduction. Sorry, all the slides for my introduction, I'm not certain where they are or where they ended up. But I'll go over the applications then, I guess. The water pasteurizer is one of our applications that we have. So basically with a big biomass cook stove, what we realize is once you're cooking very efficiently, there are lots and lots and lots of other applications, which is probably, I would say, one of our biggest challenges, aside from being a big problem to begin with, is the fact that there are lots of different things that you can do with it, which makes it hard to focus at some point. So the water pasteurizer is something that we're working on with funding and collaboration with the Oregon State University's Humanitarian Engineering Program, and they've recently gotten funding from a Venture Well program as well. So we've gotten through some of our first levels of testing in Zambia and have achieved certain levels, but they've continued to basically do iterative next steps on it. But basically you can provide 200 gallons of water or more a day or an hour. So you're basically able to service about 2,000 people. So essentially a small village or a small area, displaced area of people, or as a micro business, there are different alternatives that you could use it for. Mostly would be either as a sustainable water source or in an emergency setting. And it works with anything that's pathogen related. So it doesn't work with heavy metals, but most water filtration systems don't really work effectively with heavy metals, so it's not that different in that way. One of our biggest applications that is widely disseminated is our use with an autoclave. So essentially we have 3 sizes of stoves that will show up in one of the slides a bit later. This is our medium-sized one, where you basically take out the pot and you can put in an autoclave. And an autoclave sterilizes medical equipment and waste really efficiently. And we're able to insert ourselves into the health sector at a very important time when basically sterilization is at a critical point internationally, because here in the States we used to autoclave our medical equipment very regularly, and now we just throw it away. So we're no longer autoclaving in the way that we used to as hospitals within the US, so you're no longer sending used autoclaves being available to go to the developing world. So there's a shortage of autoclaves, there's a shortage of ones that work effectively, and our autoclaves, in addition to being able to do them quickly and with low fuel usage, it also has a ring, or it has no gasket, so that doesn't deteriorate, which is a huge issue. If you do have an autoclave with a gasket, it goes immediately. We also do high capacity canning is one of the things. It's basically the same. A canner, a pressure cooker, or an autoclave are basically the same things with a different tubes. Restaurant and catering is one of our big applications. So people feeding lots of folks. One of our most recent examples is Mercy Corps got 2 of our stoves for South Sudan, and what they wanted to do was test them within a couple of basically community canteens that were servicing the humanitarian sector as well as locals, and we've gotten our first feedback report where they're excited to be using less fuel or less time, and they particularly said that their customers are happier because their restaurant isn't filled with smoke and it's better conditions. Here in the States, we have up in Bend, where we have some folks headed for the eclipse. Up in Bend, we have these two young entrepreneurs who 2 years ago got our stove, our biggest one. They cook carnitas, and at the time, they were cooking over 10 hours. 130 pounds of meat that they would take shifts on a Saturday to cook, slow cook carnitas. They could do the same batch in our stove in 3.5 hours instead. Now they've scaled up to more than 1,000 pounds of meat every week, which if you do the math, they'd be cooking all day, every day, beyond 10 hours a day in order to do that. They just got another stove 2 weeks ago, so they'll have more capacity now as well.
And they're saving about $7,000 a year in fuel costs and about twice that in labor costs. So it's not just a stove that's good enough for Africa or Haiti, it's a stove that's literally better than the best natural gas or propane stove you could buy in the US.
So additionally, we have hydronic heating uses where you can heat tiny houses through in-floor heating systems, or in this case, it's a greenhouse that's through a pipe system. Poultry processing was something that we weren't aware of, but we apparently do a very good job at it. The same with beer and spirits. The top one is a Gen Village where there are mountains of wood that they're going through every month, like mountains of big hardwood that they're trucking in unsustainably from forests, and it's quite devastating. One of the biggest ones that we're working in right now is within the shea butter sector, which is the cosmetic that goes into cosmetics and hair products and confectionaries in Europe. And all of the shea is cooked on open fires, in a very difficult and grueling manner for women. So the 20 stoves that I mentioned that we sent off last week, or this week, was headed out to Ghana to fill that sector, which we were out on a trip in April.
What country was that from?
In Ghana.
And shea is a...
Shea is a nut, so it's a nut that goes, once it's ground up, you can see it turns into like a buttery paste. People use it in hair products, in cosmetics, and in confectionery. European chocolates prefer 20% shea and 80% cocoa because it's creamier and less expensive. So that's kind of, American chocolate doesn't use it very much. And most of it is actually eaten. We have a lot of it in our products, but there's a lot that's consumed locally on the market as well.
You have to go pretty quick here because we're running low on time. So, how much time do we have, Mike?
5 minutes.
5 minutes. Okay, so we'll go quickly through this next bit. These are just two examples of women-owned microenterprise. On the left, you can see they're using it for making palm oil. On the left, plantains. On the right, palm oil. And this is actually the same stove, same woman. They're using it for both these things. The woman is able to make about $30 per pot making palm oil, and she's able to make a business out of plantain chips where before she couldn't because the fuel used to cost more than she could sell the product for. So the stove actually makes women's enterprises possible. When we did a test out in Ghana of what the impact was comparing InStove with small wood, as you can see here, to the open fire with large wood, and it's obviously more dangerous and more uncomfortable and more wasteful. We weighed the wood, and what we found was we saved 88% of the fuel use compared to the open fire. So an important piece of our program is that we want to make sure that women are actually using the stove, that the stoves are actually being used and how much impact they're achieving. And so we do that with this stove sensor designed by a Californian nonprofit called NextLeaf. A woman who went to UCLA named Nithya designed this sensor. It records emission temperature and time, and it gives us data on the stove use that's on an online dashboard you can access from anywhere. So you can see whether or not your stoves are being used, how much they're being used, and what impact they're having. So here's a chart where you can see down in Haiti where our stoves are being used, and you can see how many times per day and what the impact is of each. So why does that matter? It matters because it allows us to make better decisions. So a stove that's not used can be moved. And that's really important with institutional stoves because it's a really big sunk cost to have a not used institutional stove versus a household stove. Another one is improved funding. So for example, from 2015 to 2017, we went from $0 to $60,000 a year for Haiti projects simply because we were able to show that we were able to monitor and report the impact data. Donors want data, partners want data. And it helps because we want transparency. So these are some headlines that the sector has gotten in some pretty high profile locations, BBC, Washington Post. We really need to be more accountable because stoves have been over-promising and under-delivering for decades. And now we finally have good technology, but people have been kind of used to hearing bad news from the sector. Well, now we can deliver, so we need to be able to show that transparently. And the impact is important because no matter how good your stove does in the lab, if people aren't using it, it achieves nothing. The impact is zero. And so we really think it's important to document what we're doing, not just come and say this will change the world, but show actually this is changing the world, this is how. So this is how we partner. We have a hybrid organization, on one side a benefit corporation that builds the stoves, on the other a nonprofit organization that partners with groups like Rotary clubs, like church groups, like nonprofits that are already doing really meaningful work, like the Nicaragua Project. So if you're doing work in the developing world, you can partner with us by just buying stoves. Maybe there's something you need it for. Maybe you know somebody that has a catering company or a food cart. Buy stoves, it helps support our mission. Or you want to buy a stove for your project. You can take a tax write-off and buy a stove from us and donate it to the project. You can identify a new use case. Suppose you know something the stove can be used for. You say, hey, you know my cousin does maple syrup rendering up in Maine. Great, we'd love to prove the test case. Maybe you have an idea for a project. We can work together with you to collaboratively develop Rotary International grants, pilot project grants, or grants for projects where you've identified a need. So we work collaboratively with you to help identify funding and get it. Or we can collaborate on proposals or contracts that are much larger. Or if you're interested, you can donate directly. We have a sign-up sheet that'll be passed around here at the end. If you're interested in getting our newsletter, sign up for that, share it. Connect with us on Facebook, social media, or just donate to us directly. And connect us to partners. We also have a conference we were mentioning earlier to Mike. The 17th to the 20th, we invite all the donors who support us, all the foundations and all the big partners that we work with to come to Cottage Grove, Oregon and share what they've learned and share how they work and share knowledge and build capacity so we can all collaborate, because there is a kind of resource problem in the nonprofit sector, but there doesn't have to be. A lot of that is a scarcity mentality. And so we want to bring everybody together who's doing the work to share and connect and learn together. So we have this conference called HEART, the Household Energy and Renewable Technology for Humanity Conference, from the 17th to the 20th of August. And so come, join us.
Right before the eclipse.
Right before the eclipse, and we have eclipse classes. So last year we were able to leverage about $600,000 in new projects, less than 10% of which went to us from this conference. So if you'd like to join us, if you'd like to learn more, if you think somebody who'd be interested, let us know. And that's it. Thank you very much. How'd I do? First question was over here. Yeah, okay, yes.
You say that there's been over-promising for a long time. I don't know how long it's been around, but I remember seeing something like this in Guatemala about 15 years ago. But it didn't look quite this technological. How long has this been around?
So the rocket stoves have been around. The question was, how long have rocket stoves been around? Rocket stoves have been around since about the early 80s. And the stove you're probably thinking about is the Lorena stove. The Lorena stove is a classic example. When the New Yorker wrote a story on the stove sector, they used the Lorena stove as an example because they looked great. They wicked the smoke out of the room and up a chimney. Women loved them, but it turns out that when you study them, they actually used more wood than an open fire. And so it was not a really effective solution when it came to impact because they used more wood. They were great in terms of health impact because they protected women from the smoke, but they were not really efficient stoves. And so that was kind of a classic case study of, this is the stove that'll change the world, but it actually was slightly worse.
It was at a Rotary project fair, actually, and one of the selling points was that it was low fuel.
So you might be thinking of Stove Team International. In 2007, 2008, Rotary International and Stove Team International worked together to open a factory down in Latin America producing cement stoves. And you saw them on the video, Stove Team International. It's run by a Rotarian named Nancy Hughes. She founded it in her retirement because she went as part of a medical mission to Latin America, and she saw that it didn't matter whether or not they were treating pneumonia or burns. The problem was, what's the root cause of this? What's the point treating symptoms of illnesses when you can treat the cause? And so instead of the medical mission, she went back the next year to do a stove project, and she launched her organization in partnership with Rotary International. So those stoves are small household cement stoves that can be built locally. And while they're much better than an open fire, there are ceilings to how efficient you can be using local materials and local assembly unless you're designing your stove for maximum impact. And so it's a great project and it's way better than open fires, but there are limits to how good you can get with the local materials. Yes?
Heat and metal don't like each other much, and the heat takes all the temper and causes severe rust.
Sure.
How are you preventing that? How long do these things last?
Sure. So the question is, how long do the stoves last? So we designed these stoves using kind of the best of modern material science. So the stoves have two different types of metal combustion chambers, either 601 or 310 stainless steel alloys, and they're designed to resist high temperature without bending, warping, breaking, melting. So they can get up to 2,000 degrees Fahrenheit without changing their shape, and they've been insulated with vermiculite, so they don't they don't absorb the heat, they refract it to the cooking surface. So with routine maintenance, which is scraping out the ash and making sure no water gets into it, because even stainless steel will rust if exposed consistently to water, the stoves will last about 10 years. And if a stove combustion chamber breaks, it's as simple as loosening 4 bolts, taking it out and putting a new one in and giving it another life.
Last question?
Yes, Mike.
Cost. You said you had 3 models or versions?
Sure. So we brought some flyers. Unfortunately, we're out of our Rotary specific flyers, but these flyers show the 3 different sizes. 20 liter, which will feed up to 45 people, 60 liter that'll feed up to 110 people, and then our 100 liter, which feeds up to 220 people. And the smallest stove is 495, and that one is small enough to be carried as checked baggage. So if you're going somewhere on a plane, you can actually bring this with you. We've done it several times going to Africa. The 60 liter stove is $895, and the 100 liter stove is $1095. So those are our 3 sizes. We'll have these up here on the table if you're interested. And as I was saying earlier, we partner with Rotary projects. So if you have a project that could use a stove or stoves, let us know, and we'll find a way to collaborate. Or if you're interested in supporting us, we can find a place for that support to go.
Okay, awesome. Thank you very much. Did you guys get it? What's your next? Where are you going next?
Back to Oregon, getting ready for the conference.
Yeah.